Yeah.
It's like 10 minutes short.
My grades at 90.
Oh, 135.
Again, if you turn in your worksheet.
I'll be fine.
And it's not bad for Darcy. It's like, that's like a 90 for a regular.
You guys turn to page 4 in your packet.
And then the other class. And you get
I'm so glad we're prepared. Only small. I am so glad.
So at least it's 0, then like, it is. 47.
I made it here. So.
If you guys can spend just a minute here to copy down the notes that I have up here. So page 4 in your packet.
I didn't find it. Yeah. It's just thinking about it, so I'm not.
Like, I really don't know. Level 5 is great, not exactly.
I should have taken another. My turn. Let me take one. Well, anyway.
So,
That's nice.
yes.
That's sort of.
Okay, so, vector, okay, the definition for vector is a quantity that has both direction and magnitude. So if you look at these, lines that are drawn on your graph, these are considered vectors because they have a certain direction. The arrow that's giving you a certain direction that this, line is going in. And it also has a specific magnitude. So magnitude is just, in this case, the value or the length or the size. If you look at these, segments, they have different lengths and they have, different directions. So we consider that a vector. Vector is a quantity that has both direction and magnitude. Okay. We'll see some real world, examples of these when we get to word problems, but for now, we're just kind of, learning about these basic, property.
What's that like with division thing at the very far left?
Yeah, so we'll get to this a little later. I want to talk about more specifically the magnitude. So yesterday, we focused our attention on using Pythagorean theorem and trig to figure out theta and figure out hypotenuse. And that's going to come into play a lot. Okay, so think of hypotenuse as the magnitude, as the size and the value and the length of your segment. Okay, and if we think of way of solving it for hypotenuse, we know c squared equals a squared plus b squared, and so if I want to solve for c is just the square root of a squared plus b squared. So we'll use that as we answer each part. But first, I want to focus on just seeing if we can practice drawing each vector diagram and the resultant vector. So resultant vector is when we're having to add two vectors together and we're trying to produce a resulting vector out of it. And then we'll find the magnitude, the size or the length of this vector, as well as we'll draw and identify the direction. Okay. So I just want to talk about these three vectors here. So you have vector A, vector B, and vector C. We're going to start at the tail and we'll go to the tip. Okay, so the tail is where the vector starts and the tip is going to be where the vector ends. And I just want us to identify the direction of motion that it's going. Okay, so is vector A moving up or down? No, so I'm going to say 0 up, and then how many units to the right? 3 units to the right. So I'm just gonna kind of give some visual notations to help me identify which direction is moving. Okay, what about vector B here? Okay, let's do up and then over. So how many units up would I have to go? Up 2. So think of it in terms of slope, right? So I'm gonna go 2 up. And then how many units to the right? 6 units to the right. Okay, so 2 up, 1, 2, 3, 4, 5, 6. Okay. And then what about vector C here? Let's go up and down first. So down. So down 6, 1, 2, 3, 4, 5, 6. And how many over? 4 over. Okay. So we have an idea of how long these vectors are, the magnitude, as well as which direction it's moving in, right? You kind of each gather the information about the left and right movement or up and down movement. We have an idea of the direction. So number one, we're going to create a vector that is twice that of vector B. So we're going to follow the same direction as vector B, but we're going to make it twice as long. So instead of going up 2 over 6, we'll just make it go up 2 over 6 and then another up 2 over 6. Okay, so I'm going to start near the bottom left corner so I can have plenty of room to move. Or you can just go up 4 over 12. That's fine as well. But I'll just go up 2 over 6 twice. So starting at the bottom left corner here, I'll go up 2 over 6. And then another up 2 over 6. So there's my vector. We'll do all the drawing first, and then we'll go back and we'll figure out the magnitude of each. All right, so for number 2, we're going to do 3a, which means we're going to make a 3 times as long, but what is this negative going to do? Yeah, that's that exactly. So if you ever see negative, you're still going to follow along that line, just going to go the opposite direction. So in this case, A is moving purely to the right, so we'll just make it swap direction and go to the left. Okay, so I'm going to start at the furthest right that I can, so I give myself plenty of room. So I'll go make A 3 times as long and also make it to the left. So the magnitude is 3, so I'll go 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, question so far? So number 3, now we're going to be adding 2 vectors together. Okay, so here it says 2 methods, but I think it's just easier to just show you one method. I think this one method is easier to do. So it's called the tip to tail method. And all we do is we're going to draw out the first vector, and then wherever the first vector ends, we're going to make the second vector begin. So the tip of the first vector is going to connect to the tail of the second vector. So we're just going to line them up. Okay. And then I'll talk about what we can do to, what's the resulting vector that's created out of those 2. Okay. So let's look at 2a. So two A means that we're gonna take the vector A and continue letting it move to the right, but we'll make it have a magnitude of 6. And then C is gonna go down 6 and over 4. So I just kind of imagine that I'm gonna need some space below here. So I'm gonna start near the top so I can have kind of predict how much room I'm gonna have to have that C to come down. Okay, so we'll start with 2A. Far left as I can start here. So A is moving to the right 3 units, so I'll make it go 6 because 2 times 3 is 6. Okay, I'm gonna label what I just drew here. Plus C. Now C is going to start here and here. So wherever C starts, I'm gonna let it start at the end of where I left off. So I said for C, I'm gonna go down 6 and over 4. Okay, any questions so far? So what is the result then? If I were to add this vector and this vector, what's produced out of it? So if I start at my beginning and I end at my end, that if I connect those two dots, that is my resulting vector. Okay. I'll use dotted line here to show the result of my resultant vector. So this is really vector 2A plus vector C. Let me have us do one here. Let me call this 3B. You guys can try this one here. Vector C plus vector 2A. And use this box here. So I want to show you here that doesn't matter which one I begin with, my resultant vector will be the same, right? Because both of these have the same direction and both of these have the same magnitude. Right, let's do number 4 and we'll go back and talk about the magnitude of each of these vectors. So we have vector B. Vector B is moving up and to the right, minus 1/2 C. So that means we're going to make C twice or half as long. And instead of going down and to the left, it's going to go what?
That's the left, right? That's
Sorry. So initially it's going down and to the right. but negative is gonna go what?
That's the line.
Wait, it's gonna go along this line here. So instead of down and to the right, it's gonna go
Up to the line.
up and to the left, right? So we're not going to create a different line. We're always just gonna go along that same line. You're either gonna go moving to the right or moving to the left. Good, so. B is moving to the right, and then -1/2 C is gonna move to the left. So I'm gonna start at the bottom, just because I know that I'm gonna have to go to the right and then to the top. So I'll start at the bottom corner here.
Show me which one of them, it's like, if it's like negative C, you'd only go either left and down or up and right.
So it depends on how a C looks, right? So if C is pointing in this direction, then the positive would just be follow the arrow here. But if it's negative, then you're gonna put the arrow on the other side of the line. You're gonna start down here, you're gonna go up to the left.
You're switching both, so you're going up and left.
Yes, yeah, you're switching both. Basically, whatever you do, you're not gonna create a new line. It's just, you're just gonna move along the same line, just in a different direction. You're right, yeah, you're changing both your directions here. Instead of down and to the right, you're gonna go up and to the left. Right, but B is normal, so up to right 6. So 1/2 of C, so instead of going 6 down and 4 to the right, I'm gonna go 3 up and 2 to the left. I started here, I ended here, so if I connect those two, and your tail is gonna be at the beginning, and then your tip is gonna be at the end.
Label all the lines.
Yes. Okay, now magnitude. So magnitude is just talking about what's the value of these vectors that we're creating. So for number 1, basically you're just going to just create a triangle out of the line that you have. So basically I'm just going to count up and to the end to figure out what the lengths are, and then those are you can just imagine drawing a triangle and figuring out the length of your hypotenuse. So here I'm going to go up how many units? 4, and to the right 12. So if you're having to imagine finding your hypotenuse or this length here, we can say the magnitude of 2b. So it looks like absolute value bars, but we're going to say this is the magnitude. So magnitude is just the square root of a squared plus b squared. So you create an imaginary triangle, find the length and the width, and imagine this vector as the hypotenuse of an imaginary triangle. And that result is your magnitude, is the length of your vector. Okay, so we're just taking time to here, we're finding the magnitude of the resultant.
Why has it been like two like lines like that so bad?
Yeah, so it's a notation for vectors that indicates magnitude.
Mhm. The slope of the line is going to help us get information about the direction. But here, it's only asking us for the magnitude. We just want to know how long this length is. Right, so imagine drawing a right triangle. The length of this is just c squared equals a squared plus b squared, and I'm just taking the square root of c. All right, with number 2, what's nice about this? Do we have to go through the trouble of Pythagorean theorem? We can count, right? We can just count if anything is moving horizontally or vertically, it's not as it's not as confusing as a diagonal. We can't count the units along a diagonal, but we can count units along horizontal or vertical. So how many units is this from one end to the other? 9. So we can just say the magnitude of negative 3a is just equal to 9.
You can never have a negative magnitude.
No, the magnitude is always positive. Yeah, magnitude is always positive. Now for number 3, we only care about the resultant vector. So the 2a plus c is just the part of the process, but the resultant vector is the vector that's produced out of these two being added together. So we only care about this one here. So I was going to create a count down and to the right to pretend I'm drawing a triangle here. So count down, how many units, and to the right, how many units. Okay, so 6 units down. And how many units to the right? 10 units to the right. Okay, so write it this way here. I can put absolute value here. I can also give it a name and call it the resultant vector for R. So I can just say the magnitude of vector R is square root of 6 squared plus 10 squared.
What if it R is like the vector?
Hmm?
What if it R is the vector?
We don't have to. We can put 2a plus c. But a lot of times I call this a resultant vector. It just allows me to give it a different name. Yeah.
You don't have to keep it in like square root form.
Keep it in square root form.
Like you don't have to like.
Yeah, I do need the square root there.
You don't have to simplify.
Oh,
Or like that.
for now, you don't have to know.
Or give like an approximate value, like decimal.
I'll prefer exact value. So if you can't reduce it, then just leave it in that form.
You need that.
There's 2 different ways. If this feels a little bit longer, but you can do it this way, or you can just call this resultant vector and say the magnitude of resultant. Yeah. Okay, number 4. And we only care about the resultant vector here. So I'm going to count up and to the right. Okay, so up 5 over 4.
We can do 3D too.
I'm sorry.
Are we gonna do 3B?
3B, okay, that's a good point. 3B should give us the same thing.
Okay.
Okay, because if we were to count, we'll also get 6 and 10. The order is different, but we're still adding the same vector, so yes, it will produce the same thing.
It's never negative.
Never negative. Yeah, your magnitude is always positive. Magnitude is just focused on how long that length is, and then direction is which we'll talk about later. Right now, we're just drawing the direction, but we haven't found a numeric value for that direction yet. So we're saving that for later. But right now, just understand that magnitude is just the length. It doesn't tell you anything about the direction. It's always going to be positive. Okay, the bottom here, it says state whether each quantity is described as a vector quantity or as a scalar quantity. So a vector quantity has both direction and magnitude. But a scalar only has magnitude. Okay. That means a scalar quantity just tells you how much it is, but doesn't give you any information about which direction it's moving. But vector has both. So a box is being pushed with a force of 125 newtons. It's scalar because do we know which direction this box is being pushed? All right, we don't know, right? So this is scalar. Okay, wind is blowing 20 knots. Scalar, right? We don't know which direction is it north, is it south, is it, okay, we don't know. So only scalar. There. Deer is running 15 meters per second due west. So this has a magnitude and it has a direction. So it's vector. 15-pound tire hanging from a rope.
Vector is direction.
Vector, yes. There's a hidden direction here. Hanging from a rope. Force of gravity is pushing it down. Okay, so your classwork is going to be page 5. So do the same thing that we did the previous page, and I'll work alongside you guys as you guys are working at this, as you guys are trying to fill this out. Okay. So number 1, I'm looking at X. Normally X would be going up 5, then to the right 5. But 1/2 X is going to do what? Up 2.5 and to the right 2.5. Okay, -3/4 of vector y. Vector y is initially going 4 up, 8 to the left. So if I just multiply 4 and -8 with -3/4, I get -3 and 6. So that means changing direction here. Instead of going up, I'm going to go down. Instead of left, I'm going to go right. So down 3 over down 3 over 6. Y is moving up and to the left. W is moving down and to the right. So I just want to give myself room here. And I'm going to go up and then come back down again. Oh, sorry, minus W. Minus W means I'm going to go the opposite direction here. So it's going to point up, right? So it's going to be to the right, sorry, left and up, and then further left and up. So negative W, instead of going down 4 over 2, I'm going to go up 4 and left 2. It's going the opposite, treating this as the beginning and that's the end. So it's going the opposite direction that W is pointing in. Because it's the same thing as Y plus negative W, right? So if you think about it in that sense, then here's my Y, here's my negative W, I'm just adding them together. think of number 5 as 2v plus a negative x. So x is initially going up and to the right, so negative x will start here and go down, right? So we'll go down and to the left. Now to find the magnitude, I'm just going count from one end to the other and go through imagine Pythagorean theorem. So this is up 2.5 to the right 2.5. So 2.5 squared plus 2.5 squared, take the square root. That's my hypotenuse. And I'll just call everything resultant vector. Oh, let's see. Resultant vectors should really be for when I'm adding two vectors together. So I'm going to still call number 1/2 x. The absolute value looks like, yeah, looks like just looks like vertical bars there, but we're going to call it magnitude. So when you get to 3 through 6, you're just looking at the dotted line that I have here. So you're just counting from one end to the other, up how many units, right how many units, and square root of a squared plus b squared. And those are your magnitude. Imagine all those lines are hypotenuse of a right triangle, and you're just counting left, right, up, and down to get to those values. Okay, on Monday, we'll use trig to find direction. But at least we see the direction and then we are able to find the magnitude algebraically. Don't forget your phones.
I said the Jack was a loser and he said, "Ah, we did it." Yeah, exactly. I said, "They got it all for it." I'm alternate. I'd rather than her. I'm scared too. I'm like, it off. That's what I'm doing. I'm not gone.
Are there anything on your website?
I'm not. I was.
And I'll put it up right now.
Yeah. Thanks.